Hello everyone. Here in this video, I'm going to explain about the ordinary differential equations. The main target is covering the CBSE syllabus of class 12. So here the definition of ordinary differential equation. Means what is an ordinary differential equation first of all? The definition here is an equation involving derivatives of the dependent variable with respect to independent variable is called a differential equation. An equation involving, right? So different derivatives of dependent variable with respect to independent variable, where actually these dependent and independent variables are involved. Let's come with that. So for example, when you have a curve y is equal to f of x, okay, it is a function. Means y is a function in x, it means. So here in this case, it is clearly observed that y is depending on x. For example, if I have y is equal to x square, right? So here in this case, if I give x value as 0, y value will be 0. If x is 1, y value will be 1 square, which is 1. X is 2, y is equal to 4, and so on. So as the value of x is changing, y value will also be changing, right? So y is always depending on x here. So that is why we call y as the dependent variable, whereas x is called as an independent variable. So from the previous classes, we already knew that derivatives are possible. Means here in this case, for example, we consider dy by dx. What does it mean? Derivative of y with respect to x. With respect to x means rate of change in y with respect to x. This is what involved, right? So when y is depending on x, dy by dx is defined. Let us consider some other variable. For example, r is one of the variable which is depending on s. In that case, derivative, rate of change in r with respect to s is defined over here. Okay. So likewise, if whatever the according to the dependent and the independent variables, the derivative will be defined over here. Yes. Here in this case, the derivative is dy by dx is involved. Of course, even further, the derivative of this dy by dx is nothing but d square y by dx square. This is the next derivative, we can say. Okay. Likewise, we can always define the derivatives, the higher order derivatives. Next, d by dx of d square y by dx square is d cube y by dx cube, and so on. So we can in generally define n number of the nth derivative also one can define here. Yeah, by the way, the notations of this differential equation, these derivatives can also be represented as this way. The first one is either I can denote this one as y1 or y dash. The notation it is. Okay. Similarly, for d square y by dx square, I can represent it as y2 or y2 like this, or y double dash also one can represent. And further, for this one, it can be represented as y3 or y of 3 or y triple dash. These are all, the representation is different here in this case. I can denote it by dy by dx as y1 or y power y dash. Similarly, d square y by dx square as y2 as this way, or y double dash also. So different textbooks will follow the different notations. Don't confuse with that. Even in NCERT textbook also, sometimes they use d square y by dx square or y double dash also. Let's see those things in the next uh, while solving the exercise problems. So now an equation involving derivatives of dependent variables. So an equation we are calling. An equation means, generally what is an equation? Equation is nothing but it is some algebraic expression equal to 0. Now in that expression, if the derivatives are also involved and if it is equal to 0, then it is called as an differential equation. Okay. So let me give one of the example for this one. So I'll consider the example as dy by dx plus k into x is equal to 0, where k is a constant, of course. So dy by dx, can you see here? It is some expression is there equal to 0 is there. So it is a equation first of all. And this expression containing derivative and some variable also is there. So, and constants are also will be there. So it is a differential equation. Next, another example is d square y by dx square. Some constant also one can write down here. 5d square y by dx square plus x into dy by dx plus 4 equal to 0. So here also this is a differential equation. It is equal to 0 form is the first of all on the right hand side equal to 0 I have written. It is an expression which is involving derivatives, constants, dependent variables as well as independent variables. So it is a differential equation. Once we know the definition of a differential equation, we should know about order of a differential equation. What is the order of the differential equation? Of course, the definition I have given here, the definition here is order of a differential equation is defined as the order of the highest order derivative of the dependent variable with respect to independent variable involved in the given differential equation. In simplest language, we can say that in a differential equation, find out the highest derivative. Okay, so the highest derivative in the differential equation is called as order of the differential equation. So I have given set of examples over here, and let's find out the order of the differential equation so that the topic will be clear for you. So this is first of all, it is containing derivatives as well as the dependent and independent variables. So it is a equal to form is there in between the expressions. So equal to 0, I can always write down by writing e power x to the left hand side. So it is an equation. I can always find out the order of the differential equation. In this one, what is the highest derivative? Dy by dx is the highest derivative. So for this example, the order is 1. And for the second example, d square y by dx square. So the highest derivative over here is 2. So order of this differential equation is 2. And next, the third case is, what is the highest order derivative here? D cube y by dx cube is appearing, d square y by dx square. Okay, don't confuse with this the power. So now what is the highest derivative only we need to find out. So here it is only the highest derivative. Okay, so d cube y by dx cube is the highest derivative. That order is 3 here. So if it is suppose d square y by dx square whole power 100 also there, then the highest derivative is only this one. So second order derivative power whatever it is, but the highest derivative here is 3. So then the order of this differential equation is 3. Okay. Let's move to the another topic. Degree of a differential equation. Yeah, you have to be very careful while understanding about the degree of the differential equation. Please focus on. So what is degree of the differential equation? Degree of a differential equation is defined if it is a polynomial equation in its derivative. Be careful. Here it is a polynomial equation in derivatives, in its derivatives. So in a differential equation, the derivatives whatever are appearing, those power should be polynomial. What is polynomial? Polynomial in generally, when you recall the 10th class definition of a polynomial, p of x is equal to an x power n, an minus 1 x power n minus 1, and so on. The last a1 x power 1 a naught, right? X power 0 is 1. So this n must be belongs to a whole number. So either it is a 0 or a positive numbers, integers or natural numbers, I should say. N belongs to natural numbers including 0. So it is a polynomial. Now to define a degree of a differential equation, the polynomial, it should be a polynomial equation in its derivatives. So whatever the derivatives are appearing over there, that derivatives power should be a integer or a, I mean it should be a power should be a whole number. So Next, if the degree is defined, suppose like if the derivatives powers are not the whole numbers, try to convert into the whole numbers. Let me explain through the examples. What do you mean by converting into the whole numbers? By the way, here, suppose if the degree of the differential equation is defined for the differential equation, the highest power of the highest derivative in it is the degree of the differential. Okay, so let me explain through the examples so that the topic will be clear. So first here I have given set of differential equations. For this one I am going to find out the degree. So first, when you consider the first example, d cube y by dx cube plus 2 times d square y by dx square whole square minus dy by dx plus y equal to 0. First, try to see whether it is a polynomial equation in its derivatives. Whatever the derivatives are appearing, their powers are whole numbers or not. Let us check. Here the power is 1, here the power is 2, here the power is 1. In its derivatives only I am saying. So first of all, they are the powers are the whole numbers. So degree of the differential equation is defined over here. Once it is defined, the highest power of highest derivative. What is the highest derivative in this differential equation? That means order of this differential equation is 3. And its power here, it means the power of this one is 1. So degree for this differential equation is 1. Okay. So the next second one, dy by dx whole square plus dy by dx whole power 1 minus sine square y equal to 0. Again, we need to check whether the derivatives powers are whole numbers or not. Here the power is 2, here the power is 1. Hence, it is a differential equation. It containing polynomials. It is a polynomial equation and its derivatives. So order is 1. Highest derivative is 1 here, right? And degree will be the highest power of the highest derivative. The highest power is here is 2. Here also it is having power as 1. Here it is having power 2. The highest power here is 2. So the degree of this differential equation is 2. And the third question, dy by dx plus sine of dy by dx equal to 0. Now check. Derivative dy by dx is appearing here as well as here. So here in this case, is it a polynomial equation? First of all, no. Because in a polynomial equation, if you see, it does not contain any transcendental function. Sine, cos, tan and all these exponential power functions, logarithmic functions will not be involved in polynomial. Since it is containing sine terms, so it is not for this kind of differential equation, degree is not defined. Of course, the order is defined. Order is 1. Of course, the highest derivative here is 1. But degree is not defined here in this case. So, degree is not defined. So, you can ask a doubt here. Even second equation also containing sine square y, no? Why the degree is defined? Just go back to the definition. The definition here is containing, saying that so the definition says that polynomial equation in its derivatives. So the derivatives terms power should be positive. Whether it is containing y or x doesn't matter. Okay. Only these term power should be positive. That is what. So whether we have sine square y or sine square x, in that case the degree will be defined. Sine of dy by dx, sine of d square y by dx square, such terms should not be involved. Okay. In that case, the degree is not defined. So let me explain one more example over here also. So that the topic will be more clear. For example, if I have dy by dx is equal to square root of d square y by dx square. Now, is it a polynomial first of all? The derivative powers are positive here in this case? No. Here it is positive, but here power is 1 by 2, which is not a whole number. Okay. So in that case, we have to convert. In the initial step itself, I told you, there are some powers. If it is not a natural number or a whole number, we have to convert. So that conversion I can make it here by squaring on both sides. So here by squaring on both sides, I will get dy by dx whole square equal to d square y by dx square. Now the degree will be defined. Here the case order is the highest derivative is 2, here d square y by dx square, right? And what is degree? Degree is nothing but the highest order derivative, its power. So here it is 1. So degree of this differential equation is 1. I hope it is clear to you. So let us go with the exercise problem from the NCERT textbooks so that the uh, order and degree of the differential equation topic will be even more clear. So the first exercise is here. The first, here on all these cases, you are going to find out the order and degree of the differential equation. Find the order of the differential equation and degree of the differential equation for the following questions. So here in this case, what is order and what is degree? Let us see. So first, to find out the order, the highest derivative. Here the highest derivative. Can you see this is d power y by dx power 4. Here d power y power 3 is there. Okay. So highest derivative is 4 here. So order of this differential equation is 4. What is degree? Degree means, I told you, it should be a polynomial equation in its derivatives. But sign of y triple dash is there. So just before I said, whenever sign of the derivative terms is there, like transcendental functions are involved in terms of derivatives, then the degree is not defined. So the degree of this differential equation is not defined. And the second question, order of the differential equation, highest derivative y dash it is. So order is 1 and degree is the power of the highest order. So y dash power is only 1 is there. So degree of the differential equation is 1. Next, the third question, if you can see, this particular question is involving different variables, whereas the first two questions involved y and x, here s and t are there. So s is the dependent variable, whereas t is an independent variable. Anyways, for this one, what is order? The highest order here is, can you see here, ds by dt, the next derivative is d square s by t square. That derivative, highest derivative here is 2. And what is degree? The highest power of the highest order here is 1. So our degree of the differential equation is 1. Next one, order of this differential equation is, the highest derivative here it is appearing is 2. So 2. Degree, what is degree? As I mentioned, it should be a polynomial function in derivatives. So it is a polynomial in function in derivatives? No. Again, transcendental functions are involved. Cos of dy by dx is there. So though the highest power here is highest power of highest derivative is 2, but here the rest of the terms are involving the dy by dx, the transcendental functions of dy by dx. Transcendental functions means cos of cos cos dy by dx, sin dy by dx, e power dy by dx, log of dy by dx. All these terms, if you are looking at in the differential equation, then degree is not defined. Whereas suppose, like, if at all if I have cos y, then the degree of the differential equation would have been defined. But here it is involving derivatives. So it is not a polynomial in derivatives, and the degree is not defined. And fifth question, order of the differential equation is the highest derivative is 2 and degree is the maximum power, highest power of this highest derivative is 1. So degree is 1. So it is a polynomial. Wherever you see the degree, different derivatives involved, that containing the powers as positive numbers. So it is a polynomial equation in derivatives. So degree is defined here. So each and every time I am repeating polynomial equation in derivatives or not. So it is must and should check to define the degree of the differential equation. Next one, order of this differential equation, the highest power, the highest order derivative here is this y power 3. So order of this differential equation is 3. Degree, to define the degree, polynomial equation in derivatives. So wherever the derivatives are appearing, that powers are positive or not, or whole numbers or not. Here 2, 3, 4. So all of them are positive. So it is degree is defined first, and the highest power of the highest derivative is 2. So the degree of the differential equation is 2. The next one, similarly one can work out and find out the order of the differential equation. Highest derivative is 3 and degree here is the power of it is 1, and for the next one order is 1, highest derivative is 1 and degree is the power. Yeah, to define again, it is a polynomial equation in derivatives. Yes, it is a polynomial equation in derivatives. So here exponential function is appearing, e power x is there. I told you already, e power x or e power y, if it is there, there is no problem at all. E power y dash if it is there, then the degree is not defined. So for this problem, the degree is defined because it is a polynomial equation in derivatives. The powers of the derivatives are positive, hence degree is defined. Here in this case, degree of the higher degree of the differential equation is 1. The highest power of this one is 1. Next, order for this differential equation is 2. Highest derivative is y double dash here. So order is 2 and degree. So it is a polynomial equation in derivatives. The highest power of y double dash is 1. So it is degree is 1. The next case also, order of this differential equation is 2 and degree to define degree, the polynomial equation in derivatives, it is fine. Sin y or sin x, if it is coming, doesn't matter as well. Okay, so the highest power here is 1. The next question is the degree of the differential equation. What is the degree of just the degree? So sine of dy by dx. So sine of derivatives are involved here. So it is not a polynomial. So it is not defined. That is the differential equation. Highest derivative here is what? D square y by dx square. So order is 2. So this is what about the first exercise of ordinary differential equation. Thank you.